Section 8.4, Volume and Surface Area. Volume is the measure of the capacity of a three-dimensional figure. It's the amount of material you could put inside a three-dimensional figure. So think about a soda can. How much material, how much soda can you put into the can? The surface area is the sum of the areas of the surfaces of a three-dimensional figure. It refers to the total area that's on the outside surface of the figure. Solid geometry is a study of three-dimensional solid figures, also called space figures. Volumes of three-dimensional figures are measured in cubic units, such as cubic feet or cubic meters. Surface area, just like we did with area in the last section, are going to be measured in square units. And here's some of the formulas that we'll use. We do not do the cone. I should have taken that off the slide. We do not do the cone. So we're going to do the rectangular solid, the cube, the cylinder, and the sphere, and we do not do the cone. And here's the surface area formulas. And again, we do not cover the cone, but we will do the rectangular solid, the cube, the cylinder, and the sphere. And again, here's our pictures. And again, we do not do the cone. So determine the volume and surface area of the following three-dimensional figure. This is like a block of wood. And so we want to do first the volume, which is the length, times the width, times the height. We simply multiply and we get 100 cubic feet. The surface area is the sum of the areas of the surfaces of the figure. And if you take a look at it, there's going to be two that are 10 by 5. There's one on this side and one on the other side. There's going to be two that are 5 by 2. And then finally, there are going to be two at the top that are 2 by 10. And that's what the formula puts together here. So if we go ahead and multiply and add those three numbers together, we get 160 square feet for surface area. And now we're going to do the cylinder, and we're going to use the pi key, if necessary, to approximate, and we're going to round off to 2 decimal places. So the volume, we did need pi here, and when we do volume, it's interesting for you to understand where the formula comes from. What we do is find the area of the base, and then we multiply it by the height. And you know the area of a circle is pi r squared, and then you multiply by the height, which in this case is 7 inches. So we're going to take pi times the radius is 3 inches, 3 squared times 7, which is 63 pi, and I'm going to suggest to you that you multiply by pi at the very end. And we're going to use the pi key on the calculator, and we come up with about 197.92 cubic inches. Now we're going to do surface area, which again has a pi use in it, because when we do surface area on this figure, we're finding the area, again, of the top and the bottom. There's two of those, pi r squared. And then the side here is basically like cutting it apart and laying it flat. It's like a big rectangle. And that's 2 pi r, which is the circumference of the circle, times the height. And again, if I drop the numbers in and simplify it, I come up with 60 pi. This comes out to be 42 pi plus 18 pi. The last thing I do is multiply by pi, and I get 188.5 square inches. Determine the volume and surface area of this sphere. Now again, in a sphere, we're going to be using pi again. The volume formula is 4/3 pi r cubed. Our radius here is 6 centimeters. So I put that into my formula. Again, I'm going to multiply by pi at the very last step. So 6 cubed times 4 and then divide by 3, I get 288. Multiply using my pi key, 904.78 cubic centimeters. And then the surface area is 4 pi r squared. Put in 6 for the radius rather. 6 squared, 36 times 4, I get 144 pi. Multiply that, I get 452.39 square centimeters. Now, we did a problem like this in the last section with area. Now we're going to do it with volume. We want to find the volume of the shaded area. We're going to do it the same way we did before. We're going to find the volume of the large figure, the volume of the small figure, and subtract. So the large area here, the large figure rather, is a cube, and inside of it is a sphere. Okay, so for the cube, the volume of the cube is the side cube, which is 4 feet, so we come up with 64 cubic feet. And then we're going to find the volume of the sphere. Now the sphere, notice this is the radius. We need the diameter, so the diameter is 2 feet. So I put the 2 in here. 2 cubed is 8 times 4, 32 divided by 3. And then I'm going to multiply that by pi, and I get 33.51 cubic feet. To find the shaded region, I'm going to take 64 minus the 33.51, and I get 30.49 cubic feet. A building contractor is building a backyard playground and wishes to put down rubber mulch to provide safety from falls. The contractor wishes to put the mulch in a pit in the area of a rectangular solid 22 feet long, 16 feet wide, and 6 inches deep. Determine the volume in cubic feet of the mulch the contractor will need. And we know the volume of a rectangular solid is given by length times width times height. But before I go on, notice that my dimensions are not in the same units. I've got feet, and then I've got inches. Okay, we need to put this into feet. So 6 inches is the same thing as a half of a foot. You're not going to be able to work the problem correctly if your dimensions are not all in the same units. So if I substitute those numbers into the formula, I come out with 176 cubic feet of mulch. Now, if the mulch costs $11 per cubic foot, how much will the mulch cost? So I'm going to take 176 and multiply it by the cost per cubic foot, and I come up with $1,936.